Welcome to the channel again, and we are going to solve design of pressure vessel today. And this is the question: a 10 meter cube capacity cylindrical pressure vessel with torus spherical heads is to be used to store water at temperature of 160 degrees Celsius. Water vapor pressure 6.4 absolute bar. The crown and knuckle radii for the torus spherical head are to be taken as 0.75 of internal diameter and 0.125 of internal diameter respectively. The shell as well as head is made of plain carbon steel with the allowed tensile stress of 85 Newton per meter square mm square. The single welded butt joint with the backing strip are used to fabricate the vessel. The total length of the vessel is limited to 5 meter. Which glass vessel is to be used for this purpose? The first one, and determine minimum vessel diameter and corresponding thickness of vessel shell. The second one, determine dimension of the torus spherical head. Assume weld joint efficiency or shell and head is equal to zero point 0.9. This is the efficiency. Okay, so in this question, what are we given with? A volume of 10 meter cube, absolute pressure of 6.4 bar, radius of torus spherical head is 0.75 of diameter internal, and radius of knuckle is 0.125 of internal diameter. Allowable stress is equal to 0.85 Newton per mm square, length is equal to 5 meter, and efficiency is equal to 0.9. Okay, so let's see, this would be the diameter, this would be the diagram here. So the yeah, and these are dots. These dots are the joints with the back strip. This is the back strip here, or in all the four joints. Okay, and these are all the dimensions to be used for this. This is SF here, this is RIC, this is TS, this is RC, this is DI, this is TS, this is SF again. Okay, so we have to find which class of pressure vessel to be used for this purpose. The initial one, the first one, how can we solve it? Let's see. The working pressure of gauge is equal to working pressure absolute minus working pressure of atmospheric is equal to 6.5 given in the question, and the atmospheric, which is equal to 5.386 bar. So let's see this. Let's say it would be 0.5386 megapascal, and as this is below 3.25, so we cannot use class third, and there are no toxic material to be used, and temperature is also greater than minus 20 degrees Celsius, so we have to use class second pressure vessel. Okay, this is pressure vessel. Okay, so minimum vessel diameter is equal to AD is equal to CD minus CA is equal to CD minus under root of BC square minus AB square from this diagram, and AD is equal to RC. RC is the RC is the torus spherical head, radius of torus spherical head, and minus under root of RC minus RIC, the knuckle radius, square minus di upon 2 minus RIC whole raised to 2. So the AD is equal 0.75 di minus under root of 0.75 di minus 0.125 di whole bracket 2 minus 0.5 di minus 0.125 di whole square. So the AD is equal 0.75 di minus 0.2499 di square under root of. So the AD will be calculated as from the previous equation, this one. The AD is equal AD will be equal to 0.25 di. Okay, so now length of vessel including straight flange means this thing. Okay, length of cell is equal to L minus 2AD minus 2TH, L minus 2AD minus 2TH. As TH is too small as compared to the length, TH is too small as compared to the length. This is TH, this portion, just this, and the length is this much. Okay, so the TH is too small, so we are neglecting this, and so the cell length will be 5 minus 2.25 di is equal to 5 minus 0.5 di. So let's say this will be the equation 2, and this was the equation first. Okay, the storage capacity of pressure vessel will be equal to volume stored in vessel cell including flange straight flange from this portion to this portion, getting it, from this portion to this portion, plus 2 into volume stored in torus spherical head excluding straight flange on both sides, from this side, from this portion to this portion. Okay, is equal to V is equal to pi by 4 di square into ls plus 2 into vh. Okay, so this will be equal to pi by 4 di square into ls plus 2 into 0.08467 di raised to 3. So this will come as this. The volume given is 10 and 3.9269 di square minus 0.2233 di cube. So this will be an equation from this to this. This will be an equation. After solving this equation, we will get di is equal to 1.6778 meter, which is equivalent to 1677.8 mm. And as of the standard, we will take it as 1680 mm. This is the standard. Okay, so the thickness of the cylinder cell. Now we need to calculate thickness of cylinder cell, and thickness of cylinder cell is equal to, the formula is pi internal pressure into diameter of internal diameter upon 2 allowable stress efficiency longitudinal efficiency minus internal pressure plus corrosion constant. Okay, but pi is equal to, the formula for pi is equal to 1.05 into working pressure. The internal pressure is equal to 1.05 into working pressure, which is equivalent to 0.5656 megapascal from the previous equation of working pressure, which was equal to 0.5386. This is okay. Yeah, and corrosion constant for the plain carbon steel is equal to 1.5 mm, and the efficiency for the glass second spot radiographed is equal to 0.85. so the thickness of cell will be 8.1016 mm, which is equivalent to 9 mm from this formula. Okay, once you put the value, you will get this 9 mm. The dimension of torus spherical head. The dimension, now we need to calculate dimension of torus spherical head, which is equal, the torus spherical radius is equal to 0.75 di internal diameter is equal to, after putting the value of di, we will get this 1260 mm, and internal radius of knuckle is equal to 0.125 di, which is given in the question. After putting the internal diameter, we'll get this 210 millimeter, which is mm. Okay, now th is equal to 1.3625. Okay, so for th we have a formula, kf constant of friction, and pi internal pressure, radius of uh, radius radius of torus spherical head, 2 into sigma allowable, stress allowable, and efficiency that we have been given in the question, 0.9, and zero point 0.2 internal pressure plus uh, corrosion constant. So this will be 1.3623 into the internal pressure 0.5656 into RC, which we have calculated over there, which is 1260, 2 into 85. 85 is the allowable stress, and 0.9 is the efficiency that we have been given in the question, and 0.2 into 0.5656 plus 1.5, which is C for the plain carbon steel. Okay, so TH will be 7.8501, which is equivalent to 8 mm, and SF for this will be counted as 3 into TH or 20, whichever the maximum. So in this case the maximum will be 24, so this is the SF. Okay, so this is the question we have solved for MST, design of pressure vessel, and hope you will understand this. And if you have any query, please drop down in the comment. Okay, thank you so much. Bye, peace.